Alright, here we go, iChem lesson 15 on types of chemical reactions. This is really just going to be the definitions and a couple of examples, but you'll want them for the activity in class tomorrow. Have the examples and the definitions in front of you. So the first type of reaction we're going to talk about is the synthesis reaction. By definition, two or more compounds or elements go together to build a more complex compound. In simple form, two becomes one. Two compounds of elements come together to form one more complex compound. The generic form of this equation, A plus B equals a molecule containing A and B. An example of a synthesis reaction using real chemical compounds is the reaction of aluminum and bromine gas to form aluminum 3 bromide. It is the balanced equation of this particular synthesis reaction. Next type of reaction is basically the opposite of synthesis, decomposition. A single compound breaks down into more elements or compounds, more simple elements or compounds. So one becomes two. It breaks apart. Decomposition. The generic form of this equation is AB, a compound containing both of those atoms breaks down into A and B separately. An example is the decomposition of hydrogen peroxide. Breaks down into water and oxygen. Notice decomposition doesn't necessarily have to break it down into its elements. It just breaks one compound down into two separate compounds. One becomes two. Combustion of hydrocarbon reactions. Definition is when oxygen gas combines with a hydrocarbon. A hydrocarbon is just something made of carbon and hydrogen to release energy in the form of light. In addition to heat and light, carbon dioxide and water are formed. So notice this generic equation has real elements put into it. So the generic equation of hydrocarbon is a molecule made of carbon and hydrogen. Now the subscripts in here may be a variety of different things. Combines with oxygen gas. Heat and light are produced, but so is carbon dioxide and water. An example of this would be methane or carbon tetrahydride reacting with oxygen gas to form carbon dioxide and water. These ones tend to be the hardest to balance in the balancing activity and in class. Today I gave you a trick when you see anyone that looks like this, and now we can give it a name, combustion of hydrocarbons. You want to balance carbons, then hydrogens, then oxygens. Alright, next type of reaction is a single replacement reaction. The definition is a single element reacts with a compound and replaces one of the compound's elements. So before we look at this in the form of chemistry, you see a compound, a couple, Fred and Wilma, and Wilma is replaced by Betty. Now Betty and Fred are a couple, and Wilma is on its own. It's a replacement of one single element. The single element is usually coupled with an ionic compound. So if you're looking at the reactants, you see a single element and an ionic compound, you can easily identify that as a single replacement reaction. So the generic equation would be A plus BX yields AX. So A replaces B to form AX, and then B is off by itself. There are two types of single replacement reactions. One of them is where the single element is a metal, so metal replaces metal. So potassium replaces copper to form potassium sulfate, and then copper off by itself. Another one is a non-metal example, where a halogen, these are all halogen if it's a non-metal single replacement, where a halogen replaces another halogen. So chlorine wouldn't replace potassium in this one, they don't have the same properties. Chlorine would replace bromine to form potassium chloride and bromine gas. Notice the halogens are all diatomic, so you're always going to have a diatomic molecule reacting with an ionic compound in the non-metal example. The last one is a double replacement reaction. So you have two couples and they're switching partners. When an ionic compound reacts with another ionic compound, the ions switch partners. So you recognize these with two ionic compounds, and all that happens is they switch partners. You have to be careful when you're writing these formulas because it's always ionic compounds. You need to start with your ions and swap and drop and make sure you have right formulas and all that jazz we've been talking about for a while. But these ones are actually the easiest, I think, to recognize. Two ionic compounds. AX plus BY yields AY plus BX. A and B basically switch places. And here's an example. Cobalt 2 chloride and sodium phosphate. Cobalt and sodium switch places, so you have cobalt 2 phosphate and sodium chloride. Don't forget to do the viewing guide. If you need to go back and get down any of these sample equations or definitions, do so. Come prepared to recognize types of reactions in class tomorrow.